Are we able to start or do we?
You can wait 1 minute, then we would be closer to your time. That's fine.
Okay.
If everybody is here, I think you can go ahead and start if you're ready.
Alrighty, thank you.
Okay. I guess we'll start then. Okay, so hello everybody. My name is Grecia Martinez.
And I'm Oscar Rivera.
And we are undergraduate students from Our Lady of the Lake University in San Antonio, Texas. So under the supervision of Dr. Charles Smith, we actually got to do a project with him on ink markers used to prevent corrosion of glass during the etching process.
So the background for this, so a little bit of information about glass etching. So usually when they're etching glass, there's usage of hydrofluoric acid, which is a very caustic and hazardous chemical. It's a very weak acid, but it's very reactive. So if you inhale it, it causes fluid buildup in the lungs, but it also can react with the calcium in your body. So now, if you don't know what glass etching is, so now there's a modern effort to it. So there's armor etch. And so what they did, they got bifluoride salts that were safer. And so what you can do is get a vinyl tape, and it's kind of like a design, and you put it on the glass. You put the paste over it. It actually blocks the corrosion of the paste. And then once you pull the vinyl off, you'll have a cool design. So what we did is the following, but here's a little bit more chemistry.
So a little bit more chemistry on HF. So before the bifluoride, they used HF. So HF is made up of the corrosive hydrogen ion and toxic fluoride. They interact with the glass in two different ways. So the first way is that acid corrodes the glass. So the acid actually penetrates the glass and allows the fluoride to go into the glass and spread and basically interact with the compounds of the glass, especially calcium. So this is actually what actually helps with the glass etching and why you get that the roughness of the glass. So if you just had fluoride itself, it cannot penetrate the glass. If you just had the acid itself, it actually does penetrate the glass. But when put together, they actually become very powerful, and they penetrate the glass and actually change the chemical structure and components of the glass. So that is basically what glass etching does.
So the specific aim and goal for this, as I said earlier, well, the objective of this project was to use something that was cost effective and just like a normal Joe, like everyone, so they could have fun and glass etch themselves in a safer method. So we wanted to use store-bought markers and wax pens and Sharpies and, Expo markers, and we wanted to see if they would stop the corrosion of these pastes.
So for stopping the corrosion, usually they have the vinyl adhesive, and that vinyl adhesive, you have to buy it. It's a little bit expensive depending on which one you get. So that's the only way we have now to prevent the corrosion. So you put the adhesive and your design would come out. So for what we did, we decided to create our own paste. We try to match it with the patent one. There is one that is safer. We try to match it, but some of the ingredients were not shown. So once we created our paste, we actually added to the glass and waited for a couple minutes or maybe hours, and then took it off, washed it off, and we had our design. So here you can see that we compare our formula with the commercial formula. We did have some of the compounds, but some of the compounds we cannot get, especially the organic solvent. So they had a specific organic solvent that they did not mention. And we basically had to try a bunch of organic solvents that we had that we can see, oh, well, this one we prefer this one because it etches better, or sometimes it doesn't even etch at all. So that's what we did. So the couple of slides, we're going to show you the formulas we try to do, and some that failed and some that actually did work.
So the first one you see here, here's the paste. The organic solvent was octanol 1. And so octanol is actually an 8-chain carbon. And so it's very non-polar. So it's very hydrophobic. So the paste components really didn't mix with it because it's insoluble with it. And then the pentanol 1, so that one you can see how that one is a little bit pasty. So what actually happens with that one is pentanol has a hydroxy group that is hydrophilic, but the rest of the body of the 5-carbon is hydrophobic. So it's actually very organic and it's very non-polar.
So for the next two, they actually did work, but one of them was ethylene glycol. This formula did actually work for the corrosion. It created a really smooth etch on the glass. And the next one is water. So this one, we decided to stick with water as our solvent because it created such a rough etch, which was what we were looking for. And the reason we believe that the water and the ethylene glycol work is due to the, yes?
Is there a question?
Hello?
Please go ahead, continue.
Okay, so why we believe ethylene glycol and water work due to its polarity.
Our audience has some background noise, so please mute yourself so the speaker can easily continue. So go ahead, please.
Okay, so what we believe is due to the fact that water and ethylene glycol are more polar than the pentanol and octanol. And the more polar it is, we believe that it can interact more with the compounds of the paste, leading to a more acidic paste. So the more acidic the paste is, the more etching it does to the glass.
All right, so right here you can see figure 1. So right here is how we prepared our glass slides for the etching experiment. So what we did is we separated all of them. And so we went ahead and we went with the wax pen, and then we went with the red wax pen, and then the Sharpie, and we used all these different types of markers and materials, writing materials. And so we put each paste that we tried, and we would try to see if they worked.
So it turned out that none of them really worked, but the Sharpie. So the Sharpie has some chemical components. We're not sure what it has, but it actually prevents the paste from etching completely. As you can see the design of the square, that you can see that the rest of it got etched, but what was covered with the Sharpie, it did not. So we believe that from this, we just started using the Sharpies. And before we knew about the Sharpie working, we tried all the other formulas, and water worked the best for us. With the Sharpie, that's the only one that did the coverage. The rest kind of just etched the whole glass completely and did not work.
And then right here, as I said earlier, the octanol really wasn't a great organic solvent for this paste. So there really wasn't any etching, and it just pretty much reacted with the marker, but didn't do anything. It didn't do anything to the glass. And then right here, so we actually tried acetone. And the reason we didn't put a picture of the paste was because all the acetone just evaporated away real quick since it has a low boiling point. And all it did to the glass was just give it a real good clean. And that's pretty much it did with the acetone. Pentanol, again, no etching was done. There was no corrosion to the glass. It just reacted with the markers.
So in this picture, these are the ethylene glycol paste. So the ethylene glycol also did etch good. The only thing that we had a chemical reaction with the colors of the markers. As you see the yellow, that was actually a blue Sharpie. It chemically reacted and the paste actually ended up etching through. So the blue Sharpie with our formula does not block, but the black Sharpie actually does block the corrosion of the glass. So then we were thinking, what if we increase the humidity? And if we got beakers and we put waters and then we put a slide in it and we increased the humidity, and it actually did etch really good. So this is with our water paste. As you can see on the right figure 9, you can see directly that the area that we covered is completely not etched at all. So that means the Sharpie did, especially under humidity conditions, did block the etching. And then I was like, well, if it works with our paste, would it work with the patent formula? So I tried the patent formula, and this actually does work with any color. It did not have any reaction, and it does block. And the good thing is that you can only wait about 3 minutes and you'll have your design. And for us, it'll take like around 24 hours or a couple hours to actually get our design. So in conclusion and future direction, specifically for our formula, I believe that we should perfect the formula a little bit more and maybe do more research on the organic solvent. And this would actually shorten the amount of time that maybe we can get it to the patent formula where it's around 3 minutes. And it's also cool because we discovered that Sharpies, instead of using vinyl adhesive tape, you don't need to buy it anymore. When you can just draw on glass with the Sharpie and then coat it, and you'll have your design. And as you can see there, we did for our professor a little sign. We did it with Sharpie, and then we covered it with the paste. Yeah, I would recommend a bigger brush if you're going to use a bigger glass. That's the only problem we had. But for all, it did work pretty well.
And we want to go ahead and acknowledge and thank our research mentor, Dr. Charles Smith. And we also want to thank the Welch Grant for funding this experiment, and the Our Lady of the Lake Chemistry Department for assisting us with this as well. Feel free to ask any questions if you have any.